Hello viewers, welcome to my YouTube channel Beauty Okene, and today I'll be taking you across some likely questions in chemistry, Jamb chemistry. Let's go straight to the point. And before that, please, I want to do something. Please, I want to acknowledge my boss. I call him my boss, Nurse Bright. He has been a source of inspiration. When I started my channel, I chatted him up and he responded. I was like, wow, if a celebrity like that can listen to me, then who am I? So I want to give a thumbs up to him. He has been doing well. I want to say thank you, sir, for all you've done. Thank you for your support. All the best, and let's go over to the board to what we have today. Okay, so let's go over. So the first question says, it said, which group of the periodic table contains the most reactive metals? Which group of the periodic table contains the most reactive metals? I believe this question is not strange, but I have a tactics, and this was what helped me while I was preparing for JAM, because there's no way I can have all the elements, upstairs. So I did something for myself so I can arrange these elements in their groups and their periods. Okay, so just follow me as I do the same. You can use it. You can also use it to solve so many questions as well. So let's go. Now the question says, which group of the periodic table contains the most reactive metals? Now the periodic table is a table that contains elements, how they are arranged in their increasing order, and how they react. You understand? Based on their family and also what based on their group. You understand? So because of that, maybe that will be in my other class. I'm going to explain the periodic table. Okay, so the periodic table contains the most which group of the periodic table contains the most reactive metals? You permit me to do something. Just do something. Let me clean up this. Now to answer this question, this is what we're going to do. The board is quite small. Now when they say reactive metals, now these are metals that are eager to lose their valence electron. What's the valence electron? The valence electron is the electron in their atomos share. For instance, some elements have 2 shells, some have 3, some have 4. You understand? When we talk about the electronic configuration of elements, for instance, we have 2, 8. Okay. Now, which element has this electronic configuration? 2, 8. This is called electronic configuration. Okay, configuration. So which element has this? What it means is that the first share has what? 2 electrons. Then the atomos share has what? 8 electrons. That's, please permit me, 2 here, 2, that's 4, 6, 8. Okay, so if we check the elements per our normal mnemonic, okay, he has large brain but could not offer full night subjects. Must all silly students stop calling the Pope Christ? That's the mnemonic, to answering the first 20 elements. Because of space on the board, I maybe just watch down. I'm going to make the list. Okay, this is a pattern I used to remember the first 20 elements. Okay, so the first one is what? Hydrogen, helium, lithium. The third, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. That's 10, right? And what do we have on the board? We have 2 and 8. When you add 2 and 8, what will it give to you? 10, right? So this element is what? Neon. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. So neon is what? 10 in number. Then the next element is sodium. That's 281. Okay, sodium is what? 281. This electronic configuration. Okay, for sodium. So this is for sodium. Sodium having a chemical symbol as what? Na. Okay, then this one is neon, Ne. It's having what? An electronic configuration of 2, 8. Okay, so this is what we should understand first. So they said, which group of the periodic table contains the most reactive metals. So I said the reactive metals, they are willing to what, lose out their electrons in their atomos share, because they are just they don't obtain or attain a duplet or what, an octet state. You understand? Now when I say a duplet, it means what, two. That's, they don't have two electrons in their atomos share. Neither do they have that's octets, that's eight what, in their atomos share. For instance, um we have okay, this one, neon is part of what, the noble gases. Okay, they always feed up, they don't react, okay. So now we're looking at the ones that are most reactive than the ones that have one. Oh god, how do I explain this? Okay, let me look for space. Let me clean up this. So when I say a duplet or an octet, duplet means two. Duplet state, duplet, it's talking about two electrons in the atomos share. Then octet, 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 it's talking about what, eight. The word oct, from your normal this saying, you have the uni, you have the bi, the dual, you have the tri, you have the tetra, you have the pent, you have the hex, you have the hept, you have the oct. From the word octopus, eight, eight. You understand? So octet is eight. So this group of elements that have either a duplet state or an octet state in their atomosphere, they don't react. But the ones that have single or three or so, they react, so that they can have a, or attain a what, a balanced state. So from this question, which group of the periodic table contains the most reactive metals that want to react so that they can obtain or attain this duplet or what, octet state? Now let me give you the what's it called, the secret on having the first 20 elements, at least to some extent. Oh, you permit me to do something. um I don't know if okay, I will clean the board. Let me clean the question, please, so I can do something. So let me use this space, okay, to do something. So this is what I did. It is upstairs. Even if you wake me tomorrow, you tell me, beauty, do this for me, this is what I can do, because it is in me. I had to deliberately sit down and learn it. So this is what I want to teach you as well. So what it is we have please permit me, we have our groups, uh and we have the period. Okay, so this is what I'm doing. Just watch me closely. So this is what I'm doing. Okay, watch me. So we have this. Okay, I have this. Now watch what I'm doing. Just watch me. Okay, so this is a group, this is a period, okay? Because the periodic table is made up of groups and a period. So this is what I'm giving to you now so you understand. So the group one, we have group one, we have group two, we have group three, we have group four, five, six, seven, okay? Just but for this limits, we're looking at the first 20 elements. So this is what you should know, just have this, just know this. So the first element is what? Hydrogen, that's H, right? The second one is what? Helium will come under. I want to do something. Okay. Of H. H. Okay. Take note. See, I wrote hydrogen under what? Group 1. In what period? This is period 1. Let me take this thing up a little bit so we understand it. So you're seeing it, right? Hydrogen here, helium here. So the group 8 elements are either called what? Group 8 or what? Group O. So they are called what? The noble gases. Okay, take note. So from the electronic configuration I talked about, we have 1, we have 2, we have 3. So we have 2. This is electronic configuration. We have 1, we have 2, we have 2 1, we have 2 2, 2 3, 2 4, comma 2 5, 2 6, 2 7, 2 8, then 2 8 1. We have 2 8 2 down to 2 8 3, 2 8 4, 2 8 5, 2 8 6, 2 8 7, 2 8 8. Then after that you have 2 8 8 1. You understand? That is saying that the element, the electrons must obtain a duplet state or an octet state. You understand? Duplet means 2, oct means 8. That is why when we get to 8, we break down. When we get to 2 from here, we now add what? Another what's it called? Electron share. You understand? So this one is hydrogen, helium, lithium. So when you add 2 plus 1 is what? 3. 2 plus 2 is what? 4. 2 plus 3 is what? 5. 2 plus 4 is what? 6. 2 plus 5 is what? 7. 2 plus 6 is what? 8. So from there you just break down the elements. Now with this I want to explain what the question says, okay? So we have hydrogen, we have lithium. So hydrogen is what? 1. Lithium, helium is what? 2. Okay? The last one is what? L, that's hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium. Okay, so he has large brain. This is L. He has large brain, but could not offer full 9 subjects. Must also people stop calling a Pope Christ. That's the word pneumenic. I'm going to break it down for you. So to fill up this thing, we're going to have Li is what? The third element. Okay, that's 2 1. We're going to break it down to what? 2 1. So we have 2 2. Okay, So we have 2 1, we have 2 2, we have 2 3, we have 2 4, we have 2 5, we have 2 6, we have 2 7, we have 2 8, we have 2 8 1, we have 2 8 2, we have 2 8 3, we have 2 8 4, okay, we have 2 8 5, we have 2 8 6, we have 2 8 7, we have 2 8 8. Okay, this is the octet now, so we now write here what 2 8 8 1. Then for calcium we have 2 8 8 2. Now if you add it together, it's going to give you what 20. So this is what for the first 20 elements. Now we are asked which groups of what the element on the periodic table has or is the most reactive metals. So we have group 1, we have group 2, we have group 3, we have group 17. Now look up. Group 1 falls under what? Hydrogen, lithium, sodium, and what? Potassium. Now group 2, look up, we have beryllium 22, we have magnesium, we have calcium. Now group 3, we have what? Boron, we have aluminium. That's they have 2 3 in the outermost shell. Okay, so which of them is the most? Now take note, group 3 are also reactive, but they're not the most reactive. Okay, now if you look to group 1 are there to react because they want to lose their single what valence electron. That's they're having one valence electron in their what outermost shell. That's we check well at the back of them, they are the same. Yes, in the electronic configuration per se, like 281, you're having one there, so they are eager to lose this one electrons so that they can what react to either attain a duplet state or attain an octet state. So the most reactive metals, okay, the most reactive metals in the periodic table is what? The group 1 element. So this is the answer. Group A, option A, that's group 1 is what? The answer. They also called what? The alkali metals. They also called what? The alkali metals. They are called what? The alkali metals. So the next question says, which type of radiation is the most penetrating radiation? You know, we have basically 3 types of what? Radiation, okay, that occurs. We have the alpha, we have the beta, and the gamma penetration. So which of them is the most penetrating? For time's sake, the answer is what? The gamma radiation, because it has no mass and what? It has no charge. So with that attribute, it becomes the most what? Penetrating. It has a high energy electromagnetic what? Force that it uses to what? Penetrate through. So the answer is what? Gamma radiation. Okay. Okay, so the next question says Duralumin consists of aluminium, copper, and dash. That is an alloy. Okay, what's an alloy? An alloy is a substance that contains 2 or more elements. Okay, chemically combined together to generate something. Okay, so we have A, zinc and gold. B, lead and manganese. C, nickel and silver. D, manganese and what? Magnesium. So what's the answer? The answer here is what? Manganese and what? Magnesium. So it contains what? Aluminium, copper, and manganese and what? Magnesium. Now, while you're watching this video, I'm going to ask you a question for you to solve and give me the answer. Okay? Okay, I think that should be at the middle of the or at the end of the class. Please remind me, I'm going to give you an assignment to what um make research about. So the next question says a secondary alkanol can be oxidized to give dash A alkanal, B alkanoic acid, C alkyne, D alkanol. Now how do we attempt this question? Secondary alkanol can be oxidized. So these two words, what does it mean? Now when we say secondary alkanol, we're also talking about what? We also refer to what as secondary what? Alcohol. Okay, secondary alcohol. Now secondary alcohol simply means that the secondary alcohol is attached to with what? A hydroxy group, that's OH. They are attached. Now what do we mean by a secondary alcohol? It simply means what? The carbon that's the carbon atom having two, that's a carbon atom, this carbon atom having two alkyl or alkyl group attached to it with what? A hydroxy group. This is what it means. Okay, so what's an alkyl group? An alkyl group is what? But I say a carbon that has what? Just that lost or loses one hydrogen yes, atom. For instance, we know the normal what's it called? Methane, that's CH4, right? This is methane. From what? The alkane homologous series. Okay, so alkane. So when this methane loses one hydrogen atom, that's it becomes what? CH3. So it now becomes what? A methyl. Becomes what? A methyl group. So this YL, okay, this ANE becomes what? YL. So do you understand it now? So an alkyl, that's alkyl, simply means what? The loss of what? Hydrogen what? Atom. Okay. So back to secondary alcohol. So if this, it means what? The carbon in which this hydroxy group, this is called hydroxy group. Okay. OH is what? Hydroxy. In which this hydroxy group is attached to between what? Two alkyl groups. So this R here refers to what? The alkyl group. That's this alkyl. So it refers to what? The alkyl group. Do you understand? Now this is a carbon having the what? Hydroxy group. So in quotes, what does it mean? Let me just express it. So if I'm to express this now, what it simply means is this. This is the alkyl group, okay? This is the carbon atom having what? The hydroxy group, okay, in it. So this is what it means. So this becomes what? The secondary alcohol, or otherwise called the alkanols, okay? You can call them secondary alcohols or what? Alkanols, okay? Now, when this secondary alcohol is oxidized, what does it mean to be oxidized? That's oxygen atom is what? Added to it. Oxygen is added to it. Now, when it becomes oxidized, what does it form? It forms what we call what? The ketones, okay? Now, when it forms the ketone, this hydroxy group now will lose what? This carbon here now, having what? Its hydrogen atom will now lose one hydrogen atom to become what? Now what it means is this: for it now to be oxidized, for this secondary alcohol now to be oxidized to form what? A ketone, otherwise called the alkanols. What will happen? Each of these alkyl group would lose one of their hydrogen again to become what? They will now, instead of them having CH, let me say for instance, they will now become what? Just C, okay? And this will now become what? C2. Now losing out what? They are now losing one what? Okay, let me calm down. Okay, now when secondary alcohol is oxidized, as if oxygen now is now added to it, it now forms what we call the carbonyl what group. Okay, now from this, when oxygen is attached to it, what happens then? It now what forms what we call the alkanoids. Okay, by so doing it becomes what? Oxidized. Okay, so and when it becomes oxidized, take note, when it now becomes oxidized, this secondary alcohol now what forms double bond with what? A hydrogen what? Oxygen element attached to it. So that's to say it now becomes what? This and this. Okay, meaning that it now forms what? A double bond for it what to be oxidized. So in a nutshell, what it means is this: that a secondary alkanol can be oxidized to give what we call what? The alkanols, otherwise called what? The ketones. Otherwise called what? The ketones. Just take note that when a secondary alkanol is oxidized, it what forms what we call the alkanols or the ketone. Now, when a primary alcohol is oxidized, it forms what we call what? The carboxylic group. Take notes of the difference, okay? Carboxylic. That is what the COOH. Okay, so this is what it forms. Take note, that's for the primary alcohol. When a primary alcohol is oxidized, it forms what? A carboxylic group. And when a secondary alcohol is formed or oxidized, it forms what we call what? The ketones. Okay, thank you. Now the next question says the next question okay. The next question says, how many electrons will be found in the nucleus of an atom with mass number 23 and what? Neutrons 17. Now this requires a technical reasoning. You have to be very technical about it. Normally, an atom has what? 3 particles. Let me use the word atom has 3 particles. I'll use an acronym for it. That's what it has. Pen in it. So an atom what contains pen. Now what's P? P is what? Protons. E is what? Electrons. And N is what? Neutron. Okay, so protons, they are what? They are positively charged what? Particles. Electrons are what? They are negatively charged what? Particles. And neutrons are what? They are just neutral. They don't fall between, what's it called, the positive or what? They're just neutral. Okay, when you say somebody is neutral, they're just neutral to yourself. Okay, now an atom contains what? These 3 particles. Now the question says, how many electrons will be found in the nucleus? Will be found in the nucleus of an atom. Now in the nucleus of an atom, take note, in the nucleus of an atom, it contains what we call Pn. It contains what? Pn. That's what? The proton and what? Neutron. So from this understanding, it said how many electrons will be found in the nucleus of an atom with mass number 23 and 17 neutrons. So from this explanation now, it means what? There is no what? Electron in the nucleus. So the answer is what? None. So when you've gotten, let me just give you something that will help you understand it more better. Let me draw something here up. Okay, so this is the atom. Okay, so in the atom we have what? This is the atom. We have proton, we have neutrons, we have electrons. Okay, so but in the nucleus, this is the nucleus now. This is the nucleus. In the nucleus, so in the nucleus of this atom, we have what we call what? The Pn, that's proton and neutron. So there's no electron there. So the answer is what? None. Okay? Can you get this down? Okay, so just take down. The next question says, when chlorine water is exposed to bright sunlight, when chlorine water is exposed to bright sunlight, the following products are formed. So it said when chlorine water, what's chlorine water? When it reacts chlorine with water, okay? That's chlorine water. Is exposed to bright sunlight. Under sunlight, it can be UV light, okay? The following products are formed. What and what is formed? Now it's very simple. First of all, it said when chlorine water. So when chlorine, you know, chlorine is what? A molecule. It's the atomic in nature. That's Cl2 react with water, H2O. Okay. When chlorine molecule, because it's the atomic in nature, reacts with water, that's what we call the chlorine water. What and what is formed, okay? It gives us HOCl and what? HCl. Now if you check too well, I was being careful, okay? The first alphabet is what? Capital letter, the other one is small letter, okay? For those that have 2 letters in their atomic symbol, or their chemical symbol, okay? So when chlorine atom reacts with water, it's going to give us what we call HOCl and what? HCl. Now what's HOCl? That's what? Hypochlorous acid. Okay, so this hypochlorous acid with what? Hydrochloric acid. Okay, so when this chlorine molecule reacts with water, it's going to give us HOCl plus what? HCl. And please take note, this is a major thing that what it forms. So when chlorine reacts with water, okay, we have HOCl plus what? HCl. Now before that breakdown, now take notes. Let me just calm down. Okay, relax. When this chlorine atom now reacts with oxygen, it's going to give us what we call hypochlorous acid and water. Take notes. Now when this hypochlorous acid is now further broken down, when it's now broken down by the what? UV light or the sunlight, what happens? It now hits what we call, it gives us we have HCl and what? Oxygen molecule. Let me use heat, sunlight here. Okay, so you write sunlight. Okay, so this is what it does. Now we check 2 well first to balance the equation. I think that will take us to the next thing I will treat on balancing of equation. We have 2 atomicity of chlorine here. Okay, we check one, we have 1 here, we have 1, that's 2. Okay, now we have 2 atomicity of hydrogen here. If you check 2, we have how many here? 1, we have 1 here, so it's balanced. How many atomicity of oxygen we have? We have 1 here, we have 1 here. Okay, so it's balanced. Okay, so looking at this now, we have this hypochlorous acid is now broken down to what we call hydrochloric acid and what oxygen molecule. So this is what the decomposition of chlorine water yields. So we have A, HCl and Cl2 only. No, we check, so we have this, okay. So we have that, okay. So B, we have HOCl and Cl2. No, even from this option we don't have what's it called, HOCl and Cl2. So C says we have HCl and O2. We have HCl and O2. D, we have HOCl and O2. So from the further breakdown, this is the first stage. Okay, so this is the second stage, the final stage. This is where the decomposition takes place. So at this decomposition of hypochlorous acid, it yields what? HCl and what? Oxygen molecule. So the answer here is what? C, HCl and what? O2. Okay. So if you found value in this video, please do well to subscribe, and I'll be giving you the latest information so far concerning Jamb registration and other informations. Okay. Now before I leave, I'm going to give you something to work on. So you share the answer in my comment section. Also, please do well to like this video, do well to comment, and do well what to share. So the question is this: brass is an alloy of dash. So brass is an alloy of what? Determine the answer. So thank you for watching. Thank you for being there for me, and also please do well to subscribe, comment, and share. Bye for now.